Hello class, we're moving on to our next section of chapter 12 on surface areas of pyramids and cones. So the vertex of a pyramid is which a base is a polygon and the lateral faces are triangles with a common vertex. So the lateral faces are always going to be triangles and they always go to a single point. To know what's a pyramid and a prism has two faces while a pyramid only has one. A regular pyramid is a regular polygon for a base and segment, that is an and sign, joining the vertex and center of the base is perpendicular to the base. So I did leave a couple of words out due to space, but regular pyramid has a polygon for a base, and the segment joining the vertex and the center of the base is perpendicular to it. So we'll see a couple of examples of that one. The slant height of a regular pyramid is the height of a lateral face of a regular pyramid. The vertex of a cone is a vertex that's not in the same plane as the base. A right cone is a segment joining the vertex. This does say joining, pardon the handwriting. A segment joining the vertex where the center is perpendicular to the base. So very similar to a regular pyramid. An oblique cone is where the segments, or the segment, is not perpendicular to the base. The slant height of a right cone is the distance between the vertex and a point on the edge of the base. And our last definition for 12.3 is the lateral surface area of a cone, and that consists of all segments that connect the vertex with points on the edge of the bases. So those are definitions for 12.3. We go on to the next page where we'll go over some core concepts and definitions, a little bit more definitions on how to apply these to actual cones and pyramids. So our core concept is the lateral area and surface area of a regular pyramid. And so we have the lateral area is 1/2 the perimeter times the slant height. So the L here is for the slant height, and remember, it's perpendicular to the base of your pyramid. The surface area is still the area of that base plus that lateral surface area. And of course, lateral surface area is 1/2 of the perimeter times the slant height. So let's do an example. In this case, we have a hexagonal pyramid here because it is 6-sided. Did my best to try to draw as best as I can, but here is where that comes into play. So L is equal to 1/2 the perimeter times the slant height. So the perimeter we need to find of the base. Of course, it is a hexagon. So we have a hexagon here. And so that means it has 6 sides. And each side is going to be 10. I forgot to add that. Each side is 10. So the perimeter is 60. And the slant height I've already given here is 14 feet. So the lateral area is 420. And that's 420 feet. Now for the surface area, remember we're taking the base area. So if we want to find the base area, of course we have a regular hexagon still, so we need to apply the regular polygon area. So that's 1/2 the apothem times that perimeter. So I have 1/2, and the apothem, thank goodness, is given to us, and that's 5 square root of 3. And we already found the perimeter, which was 60. And so I'm going to plug this all in. So I have B plus L, and B we already know is 1/2 times 5 square root of 3 times 60. And we're going to add it with 420, and you can plug this all into your calculator. If you want to simplify, you do end up with 150 square root of 3 plus 420. And as a decimal, you end up with 679.81 feet squared. Okay, so that is one example for using lateral area and surface area for a regular pyramid. So we're going to move on to the lateral area and surface area of a right cone. So the right cone, again, a cone has a circle involved, so we do have pi times the radius. And for a surface area, we do have the area of a circle, which was pi r squared. And so we still have L because we still need that slant height. So given our example, we do have a cone drawn down here. And so we need pi r times the slant. And in this case, I don't have the slant. I am missing L here. And because this is a right triangle, I can use Pythagorean theorem to find L. So remember, we have L, in this case, is our hypotenuse. So remember, this is the hypotenuse because it's across from 90 degrees. So that means I'm going to add 6 squared plus 8 squared. And if I were to type that completely into the calculator, I end up with 10. And so L is 10. So now I can plug it in. So pi times r, which is 6, the radius, and we already found L to be 10, so I have 60 pi. So I'm going to leave it in terms of pi. You may type it into the calculator. You get 188.5, but I'm going to leave it in terms of pi. So now I'm going to apply surface area. And of course, there you have the area of the base. The area of the base is pi r squared. So these mean the same thing. So pi, and then we have r, which is 6. We're going to square it, and plus pi r l, which I found to be L, and L is 60 pi. So I have 36 pi plus 60 pi, and I end up with 96 pi. So So that is an example of applying a cone, and yes, you will need to use Pythagorean theorem to find the slant height sometimes. So remember that is always needed in order to find the slant height. We have gone over Pythagorean theorem before. Remember, it is a squared plus b squared equals c squared. And if at any time we are finding a side, we're going to subtract. If we are finding the hypotenuse, we're going to add. So please keep that in mind. And we're going to go on to the next page where we have some extra examples. Okay, on to our extra practice. For number 1, we have to find the lateral area and surface area of the regular polygon for 1 through 3. And so let's go ahead and start with our first one. So remember, lateral area, it's 1/2 the perimeter times their slant height. And so we have 1/2. We need to find the perimeter. So the perimeter of this, we know this is a 6-sided polygon, so a hexagon. And all sides measure up to 18. That's the base. So we have 8 times 16 for the perimeter. Or I'm sorry, 18 times 6 is the perimeter, and our slant height is given to be 17. And so when I type this into my calculator, I end up with 918. Now we're going to go on to finding the surface area. So remember, the surface area is adding the base area plus the lateral surface area. And remember, we have a hexagon here, so if we want to find B, we're going to take 1/2 the apothem times that perimeter. So we have 1/2, and the apothem is already given to us to be 9 square root of 3, so lucky for us. And then we have the perimeter, which is 18 times 6, and we get 108. And so we're going to add that into our equation. So the surface area is 1/2. Then we have 9 square root of 3 times 108, and we're going to add it with our lateral area, which was 918. And into our calculator, we end up with 1,759.78. So there's some steps I've skipped, but I know you guys know how to type into the calculator. So moving on to number 2, we have to find the base area, and we need to find the perimeter. So remember, L equals the perimeter 1/2. Don't forget that 1/2 times the slant height. So we have 1/2, and we need to find the perimeter of the triangle. So the triangle in this case has 3 sides, and each side is 2.4 millimeters. And then we have our slant height given, which is 3.7. So if we were to type this all into our calculator, we end up with 13.32 millimeters. Now for our surface area, we do need to find the base area and add it to our lateral surface area. So B is finding, got to find the height of this triangle. And the height's not given, so I have to find it. Remember, we talked about 30, 60, 90 triangles. So the base was 2.4. So if I were to cut it down the middle, I end up with 1.2 on each side. So that makes the apothem 1.2 square root of 3, because we talked about 30, 60, 90 triangles. And so for the base area, which is 1/2 base times height for a triangle, we have 1/2 the base, which we know to be 2.4, because we have to add them together, and then times the height, which we found, which is 1.2 square root of 3. So I'm going to add that into my base. So we have 1/2 2.4 times 1.2 square root of 3, and we're going to add it to our 13.32 millimeters. So it's a lot to type in. If you're simplifying, you get 1.44 square root of 3 plus that 13.32, and as a decimal you end up with 15.81. And this is millimeters squared because we are dealing with area. And so that is number 2. We are going to take a brief moment. I will upload a second video with the rest of the examples, but here's number 1 and 2. But number 3, as a walkthrough, we are talking about a square pyramid that has a height of 16 and a base edge of 60 millimeters. So if we are to draw it, we do have a square as the base. So remember, squares have all the same measurements. And then it goes up to a single point where all the lateral areas or lateral faces are triangles. So I'm going to resume this video momentarily after class has started. Thank you so much.